and I cut out the stuff
Okay.
later. So I go with 12 minutes. It will be a super rush. There will be an exam in the end, so pay attention, please. So I'm Christian Glahn. It's really unfortunate that I cannot be with you in Newcastle today. The problem is that our first our first semester starts right this week, and tomorrow I have to stand in the lecture hall in the morning, and there's no possibility for me to get back from Newcastle on the very same day. That's why I have to be here remotely, unfortunately. And I miss you people. I miss ECTEL a lot. So today I will talk about a contribution on towards educational patterns for teaching computational thinking using robots. And towards means this is work in progress, so we don't have answers for everything. Everything is embedded within the Coteli project. Let me switch over to this. Within the Coteli project, and the Coteli project is funded by the Erasmus Plus program and the Bovetia research program from Switzerland, and is brings together 16 institutions from 6 countries. So here we have a bunch of logos of all our partners. So the work I present today is in parts a result of our collaboration, and in part a little rant about how not to do things. So our project objective, very briefly, for the Coteli project is to create plugged-in, unplugged, and technology-enhanced learning activities for CT, computational thinking learning, and assessment using robots and tangibles, considering the diversity of each country and the needs of the students for inclusion and diversity criteria. Okay, that's a bit of a mouthful, and I know all of you are now fully aware what we are doing. Probably not. So what we are doing is actually create playful learning experiences for computational thinking, learning, and assessment for all pupils in primary schools using robots, tangibles, and some unplugged stuff like board games and these kind of things. And because we are in EduRobotX, I like to remind you what a robot is. A robot is a programmed actuated mechanism with a degree of autonomy to perform locomotion, manipulation, and positioning. This comes from ISO, and we see we're deep in academic waters here when it comes to vocabulary. So let's boil this down for primary school levels. So a robot is a physical computer, something you can touch and carry around with motors attached that can move, build, or break things, including itself. So it can move itself around or move other stuff around, build stuff, break stuff, and the breaking is really, really nice for young students. They do that a lot. So if we strip off the motors from a robot, then we call it a tangible, just because we're there. This is something that we touched in the discussion of the previous presentation when we talked about richer technology-enriched environments. Then we talk about robots together with tangibles that students interact with. Okay, so when we look at the didactics of using robots in the classroom, we cover basically 3 areas from the area of computational thinking. One is mechanics, because robots are mechanical pieces of hardware. Then we have computation and logic, and we have sensors and actuators that move things around. And whenever we look at the didactics of using robotics in the classroom, we often find some kind of intersection of these 3 areas embedded into one curriculum. And you can imagine this is terribly complex for students, particularly in the primary school level, to appreciate, apprehend, and understand. So there's a bit of research that looked at computational thinking education using digital tools and non-digital tools. And I draw here on the framework of Khalilioglu and Brackman from 2016-2017. And they dissected the entire design space for computational thinking education into digital and non-digital tools on one-dimensional area, and direct experiences and represented experience. A direct experience would be that computational thinking is the tools that we use is embedded as the subject matter. And a representative experience is something where the robot would, or any other tool, would stand for the computational thinking concept that we're dealing with. So when we talk about plugged and unplugged education or concepts and or learning designs, then we look at two quadrants in this dimensional sphere. The first quadrant is direct experiences and digital tools, and there we talk about computational thinking using digital tools. Then we talk about plugged experiences. Then we have the non-digital tools and represented experiences, and then we talk about unplugged experiences. The problem is here that many researchers do not agree what non-digital tools are. For example, Leo, they mentioned that robots belong into the unplugged world, but undoubtedly robots are certainly computers with motors, so they fall into digital tools. Let's fill in the other remaining quadrants in order to make sense of the whole thing. So the easy bit is direct experiences using non-digital tools. So computational thinking without digital tools is about theory. Yeah, very simple. Don't talk about this. Now let's have a close look at represented experiences using digital tools. So we hide the computational thinking concept within a digital tool, so the students interact with the tool and learn about the concept without actually programming something like we saw in the previous presentation. In this case, I like to talk about augmented learning designs or augmented experiences, where robots and tangibles basically augment our experience space rather than being the subject matter themselves. And we draw a couple of icons here, and this is for you to remember because this comes back later also in the exam. So plugged activities have a plug with a tick mark. The augmented activities have a plug with a minus. That means that it doesn't need to be plugged. And unplugged is with an X because there are no plugs. And okay, let's have another, because computational thinking is too easy to do by itself, right? So we also cover diversity aspects in our project together with computational thinking. So we draw something similar with the quadrants, but this is not as elaborated because there's very little research here. So still we have digital and non-digital tools, we have inherent diversity and external diversity. Brief example, inherent diversity is something that you have in your class. These are the cultural, cognitive, behavioral, strategical, gender differences between the students in the class. This is something that is present every day that you need to consider as part of your lesson planning as a teacher. Whereas external diversity is something that is not present in the actual situations in your classroom, that you cannot control, that you have no examples, that you don't need to consider as a teacher as part of your learning design. This could be something like color blindness. When you want to address color blindness with students, you need to show them how colorblind people experience the world, because you may or may not have students who are colorblind. And unfortunately, we cannot split the quadrants here. So what we came up with is on the inherent diversity, when we need to cover the student differences, we talk about adaptivity in our learning experience designs. And when it comes to external diversity, we use the robots for presenting or representing that kind of diversity factor. So this is a groundwork. These are the fundamental pattern structures where we started from. So now we want to move on into educational patterns, and that means structuring the process of getting to know, the learning process, that is. So our main question is here, how do we describe playful learning experiences? Because that's what we are after. And how do we describe them so teachers can use and share these experiences and remix them if they like? So first of all, what is a playful learning experience? It's a sequence of steps that encourages learner agency and learner creativity. These two elements are essential for playful experience. If you strip the agency that learners can actually do something freely by themselves or their creativity, often your experiences won't be as playful as you want. So how do we describe them? There's a quite old structure for describing these kind of learning activities. This is from Rob Coper, taken from Rob Coper. So we have a bunch of metadata, we have a bunch of conditions, and then we have the instructions how we organize our in-class activities with the students. And that's what they call play. This comes from the learning design, IMS learning design specification. This is the fundamental principles, and many organizations, particularly the Open University in the Netherlands, they still follow that principle. So we came up with a bunch of description for these plays, and that's what we collected in the project. So a bunch of text, and it's very easy to understand and very easy for you to see what's going on. So keep reading as I'm going forward. So the question here is, where is the creativity and where is the agency? You already have spotted where these are while reading through the text on this slide, right? So for me, it's still hard even reading the text and understand what's actually going on, what's the educational rationale behind it. And that makes it super difficult for teachers to understand what's actually going on and how do they translate it into their classrooms. But there are other representations for designing experiences. One of them is taken from the business world. This is the business process notation model notation. So there we have activities, we have events like beginnings and endings and interfaces and signals, and as well as transitions and decisions that move between the different activities in our experience. So the overall experience is everything put together, and then we have learning activities, individual learning activities at a smaller step. If we dive even deeper into the learning activities, we end up with something probably similar to Engelström's activity theory model. This is a very famous triangle, last published in 2015, or at least that's where I took the diagram from. And he dissected activity and came up with a whole bunch of elements. The problem with triangles is that they hide important things. So what I did a couple of years back, I flipped the whole thing on top and rearranged the triangle so we can see new things going on. And this gives us an experience where Engelström started from the people, I started from automation. And suddenly the same concepts, same principle, emphasize concepts from the automation perspective, which is quite nice. And it took a little bit rearranging further that helped us to see more profound educational design elements, like how do the different concepts of an activity fit together with our learning design experience that every teacher knows, like interactions, processes, and environmental perspective together with the learning outcomes. And because this is super simplified, we opened it up into a more canvas style learning design field. And this canvas basically helps us to understand the activity design space. This is not a pattern. This gives us like a whole bunch of different elements that we need to consider when we talk about educational activities. Yeah, and this goes way further than Engelström even thought of, and this goes further than many learning design theories focus on. So we try to integrate as many of these theories as possible, including Bloom's taxonomy, if you ask me later. So where are robots? Our Coteli robots are smack in the middle. They can be part of the interactions of the subject matter, like in direct experiences, or they can be part of the learning environment, like tools or resources, or contextualizing the environment, and serve different purposes in different kinds of activities. So we ask ourselves, what are patterns? And patterns are basically tools to pre-structure this complex design space, because we cannot expect any teacher to look at each different facets individually in order to move forward with their lesson planning. Very difficult to do. So we use, I use a whole bunch of educational activity patterns. This one is taken from Leclerc and Pumet, who identified 8 learning events, such as receiving or presenting, exploring, practicing, creating, meta-learning, reflection, experimenting, debating, and imitating. And they identified these pattern structures of learning activities from teacher classroom experiences. So they looked at teachers' lesson planning and identified the different kinds of learning activities going on in school classrooms. So we took that and we create a design tool that helps lecturers and teachers alike to reflect on what's going on in their classes, in their lesson plans, in order to explicify their educational intentions. So let's put this together for our robots. So we start again from this activity description. Actually, this is a flow of 3 activities, 1, 2, 3, with sub-activities marked here with bullet points. And let's move this to a more understandable representation. So the very same experiences in BPNN would emphasize that we have our receiving presenting pattern for the introduction and a loop of imitation patterns where we have various very similar activities with different parameters that are going on, and then we have a final imitation activity that is going on. And these activities are concerned with these kind of robots. Yeah, they are playful, they are nice, they are Lego. We should play more with Lego, as we heard. Okay, but now we can ask, where's the agency and the creativity of the students if they are just getting confronted with something by the teacher and then imitating what the teachers are doing? And yeah, this is a very hard thing to do in learning design, right? But it's good to have a better understanding what's going on in the learning design in the first place. And this helps us to visually understand already what's going on and helps us to see, okay, what part of this process I want to take out and bring into my class and remix and do something new with it. But now let's go to the playful part, because playfulness doesn't have to be difficult. And I show you another robot here. This is a different robot. We use a whole bunch of different robots in the project. And this is a pluggable interface. We can build stuff also with Lego, but it's not the Lego robots. So you don't have to think too much about the mechanics and sensors and actuators. It has everything built in already. So we use a pattern that we implemented quite successfully over the last couple of years. So this pattern is a sequence of exploration, creation, and receiving. And what you see here is the plugged with a minus, which means that these are augmented learning experiences. So the robot is not used for computational thinking as a subject matter, rather than it represents the computer that implements an algorithm that in this case is drawn on paper. So the activity follows like this. First, the students understand how is the robot behaving with certain kinds of sensors and motors and stuff. Then they create something by themselves using this exploration experience. And then we flip over the receiving part where the students tell to the class and the teachers what they came up with as a solution. That brings much further the creativity and the agency towards the classroom. And this is what it looks like. This is with our ETL community students. Look, there's Maria. Over here, Maria. And it's a messy interaction, but it keeps people smiling. And what a wonderful thing about this pattern is that we are not bothered about diversity issues, because through the exploration and the creativity, the diversity is embraced and included in the learning experience rather than externally set up because you need to have special imitation exercises for people with different experiences. And that shows us that the same principles can be implemented quite differently using different educational designs, using robots in the classroom, which is kind of amazing, I think, and already quite useful outcome for our purposes. So the power of patterns, in my understanding, to conclude this, is firstly that they help us to understand way easier what is the educational flow and what is the educational intention of a learning experience. They help us to identify the educational principles underneath, and that helps us to reflect on what we're doing as practitioners. They help us to create smart learning experiences way faster than just typing complex descriptions down. And they're super easy to remix and share because we can take part of an experience, like one or two activities, and set them into a different scenario, and it still works out because they pre-configured our design space. And we did this with this experience. So we have a whole bunch of activities that follow exactly the very same principle. And all we do is the stimulus, we change the stimulus to the students. So one stimulus is create a racetrack for the robot. The second stimulus, make the robot follow your hand. The third one is bring two robots together so they collaborate. Yeah, but the whole activity principle is the very same. It makes remixing and sharing super easy and super fast. The work is not done. We have a whole bunch of next steps for coming up, but I may talk to you about this in the questions. So thank you very much.
Thank you, Christian.